Okay, so in this video, we are going to take a look at graphing quadratic functions in vertex form. So vertex form, remember vertex form is where we have y equals, and this is where we have the a out front, and then in parentheses we have x minus h squared plus k. So anytime we want to start graphing, the most important thing that we can do is find the vertex. And that's what it tells us here. It says plot the vertex. So I'm looking for the vertex. In vertex form, my vertex is right here. It's h and k. So if I look at the function I've been given, which says f of x equals 3x squared. Now the h is the number that's being added or subtracted to the x. And there's not a number there, so that means that that would be a 0. And the k is whatever's being added onto the end. And as there's nothing being added onto the end, that would also be 0. So that would tell me that my vertex is at 0, 0. So I would plot that on my graph. And if you notice now, we could kind of move this around. But let's finish reading the directions. It says, then plot another point on the parabola. Plot another point. Well, I know that this is at 0, right? So to plot another point, well, I'm just going to move over and say, well, this is 1. I'm going to plug that in and see what I get. So I'm going to do the next one. I'm going to say, okay, so that is f of x equals, I'm going to put 1 exactly where the x is. So I'm going to put in 3 times 1 squared. Well, this would equal 3 times, well, 1 squared is 1, and 3 times 1 equals 3. So my coordinate here is I input 1 for x, and f of x, or y, equals 3. So my coordinate's 1, 3. Let's go ahead and plot that. So I come back over here, and I'm going to go 1 up to 3. I'll put my next point. Now remember, because it's symmetric, as soon as I add 1 point, or 1 new spot, it's going to automatically mirror it on the other. So my vertex is at 0, 0. The axis of symmetry would actually be x equals 0. And then I have 2 points which mirror each other for symmetry. So this one is very similar. Let's take a look at one that might look a little different. So this one looks a little bit different. Same type of thing though. We are still using our vertex to plot or to start graphing. So here's my f of x equals 8x minus 10. So thinking about that, remember that that would be like saying y equals, right? And I'm looking for the h and the k. So y equals a x minus h squared plus k. So my vertex is, well, what's being added or subtracted to the x squared, so that would be inside parentheses. Since there's nothing in parentheses, I'm going to say, well, that means that the h must be 0, and the k, what's being added to the end, is negative 10. So that means that my vertex would be at 0, negative 10. Oh, let's try that again. I hit that. There we go. Up next, I need another point. Well, if I'm at 0, negative 10, 1 would be pretty easy to put in. So let's try putting 1 in. So that says f of x equals 8 times 1 squared minus 10. Or always exponents first. 8, 1 squared is 1 times 1, which is 1, minus 10. Multiplication before subtraction, so 8 times 1 is 8, and then we subtract the 10, and 8 subtract 10 is negative 2. Therefore, my next point would be 1, negative 2. I input 1, my output was negative 2, so 1, negative 2, and when I click there, I'm going to get a full parabola. Okay, we'll take a look here at another one. I have f of x equals 2/3 x minus 2 squared minus 4. So remember, this is the same as saying y equals vertex form is ax subtract h is the formula squared plus k. So when I look here, my vertex is hk, looking for h and I'm looking for k. H is, well, it's positive 2 because the formula is negative, so it says positive 2. The k is plus 4, which makes it a negative 4. So negative 4 here, so 2, negative 4. I'm going to place that on my graph. And that's my vertex. So now I need to go find another point. So if this was 2, I could go either direction. I could use 3 or I could use 1. I'm just going to go ahead and use 3. So I have f of x equals 2/3. In parentheses here, I'm going to have 3 minus 2 squared minus 4. So this would be 2/3 times 1 squared minus 4, which would just equal 2/3 times 1. And if I do this, I'd have 2/3 minus 4. Well, then I would have to have like denominators, right? So 4, I would put that under 3. And that would give me 2/3 minus 12 over 3. And that would simplify down to negative 10/3. Now, if you notice, that's going to be really hard to get on this graph. So maybe that was not the best number to pick. So what we would do is we just try a different number and see if we could get something that was a little bit easier to work with. Okay, I'm going to move over here to the other side so I have a little bit more room to work. And because I did not like the way that was going to graph, I'm going to try it again with a number that might work a little better. So I have 2 over 3. Sorry, sometimes this pen does not work very well on here, so let's try that again. I have 2 over 3, and then I'm going to use 5. So 5 minus 2 squared minus 4. So that would be 2/3, and then 3 squared minus 4. Well, 3 squared is 9. So now I have 2/3 times 9 minus 4. Now what is 2/3 times 9? Well, that would be like 2 times 9, which is 18 over 3. And 18 over 3 is 6, so I'd have 6 minus 4. And 6 minus 4 is 2. So when I input 5, my output is 2. That's a lot easier to work with. So when I input 5, my output was 2. And again, I have a perfect parabola. So if at first you pick a coordinate and you're like, okay, I tried this x, but I really don't like my answer, that's okay. You can use any of the coordinates that land on this grid. So if 1 didn't work, try 3. If 3 doesn't work, try 4. Pick a number that works best for you.